You've seen them on highways, shiny silver tankers rolling smoothly under the sun. They look simple, just a big metal barrel on wheels. But inside those walls, there's a world of pressure, valves, and moving liquid, all engineered to carry one of the most volatile cargoes on Earth. So, what really happens inside an oil tanker truck? Let's start by breaking down the main types of oil tankers. Because believe it or not, there's more than one way to move fuel. Straight trucks, also called bobtails, are smaller units used for local deliveries. They usually carry around 3,000 to 5,000 gallons of gasoline or diesel, perfect for refilling gas stations within a city. Then, there are semi-trailer tankers, the giants you see on highways. They can hold up to 9,000 gallons of fuel and are divided into 4 or 5 separate compartments. Each compartment carries a different product, regular, premium, or diesel, to prevent mixing and to keep the load balanced. Heated tankers are built for thicker materials like asphalt or heavy oil. They use insulated walls and internal heating coils to keep the cargo at the right temperature. And finally, chemical and vacuum tankers, designed for specialized or non-flammable liquids with stronger pressure ratings and corrosion-resistant linings. Each type is engineered for a specific task, but they all share the same mission: moving liquid fuel safely from one point to another without a single drop lost. From the outside, an oil tanker looks like one massive tube, but inside it's divided into a series of independent compartments, each one sealed, monitored, and designed to stay stable on the move. Most highway tankers have 4 to 5 compartments, each holding about 1,500 to 2,000 gallons of fuel. They're separated by bulkheads, solid walls that prevent products from mixing, and reinforced with baffles that break up the liquid motion. When a tanker breaks or takes a turn, thousands of gallons of fuel shift forward. Without baffles, that surge could throw off the truck's balance. So the walls inside the tank have openings that let the fuel move just enough to equalize pressure, but not enough to build momentum. The tank itself is made of aluminum alloy, chosen for its lightweight and corrosion resistance. Inside, every weld is pressure tested, every seam sealed, and the whole vessel is slightly pressurized, usually around 2 to 4 psi, just enough to maintain structural integrity and prevent vapor buildup. It may look calm from the outside, but inside, physics and engineering are constantly working to keep thousands of liters of fuel under control. At the fuel terminal, the loading process begins, but it doesn't happen from the top. Modern oil tankers use a method called bottom loading, a system designed for safety, speed, and cleaner air. Under the trailer are API connectors, one for each compartment. When the truck backs into the loading rack, hoses are locked into these valves from below. Before any fuel moves, the system performs an electronic grounding check, confirming that the truck is properly bonded to the terminal. No ground connection means no flow. Once connected, fuel is pumped upward through internal lines, filling each compartment from the bottom up. That prevents static buildup and reduces vapor turbulence. But while liquid goes in, vapors have to come out. A separate vapor recovery line connects the tank's top manifold back to the terminal's storage tanks. This creates a closed loop. The air displaced by incoming fuel is pulled back, condensed, and reused instead of vented into the atmosphere. Each compartment fills automatically, monitored by optical overfill sensors that stop the flow at about 95% capacity. And with the dead man switch, the operator must stay present. If they release the control, the flow shuts down instantly. It's a precise process. No fumes, no splashing, and no sparks. Just physics, sensors, and a closed circuit of fuel and vapor moving in perfect balance. Safety on a fuel tanker isn't just about careful driving. It starts before the truck even leaves the terminal. Each compartment has an overfill protection system, usually an optical or thermistor probe that senses when the liquid reaches a preset level. If the fuel rises too high, the signal cuts the flow instantly. No guesswork, no overflow. Along the bottom piping, emergency shutoff valves are built into every outlet. If a hose ruptures or the truck is involved in a collision, those valves slam shut automatically, sealing the cargo in seconds. Up top, pressure vacuum vents keep the internal atmosphere balanced. When fuel expands in hot weather, these vents release excess pressure. When temperatures drop, they let air back in, preventing the tank from collapsing. The entire system is surrounded by rollover protection rails and thermal relief valves, simple mechanical backups that release heat and pressure if a fire occurs nearby. Every hose, coupling, and fitting is engineered for one thing: containment. Even with tens of thousands of liters of fuel on board, the system is built so that nothing escapes. Not a drop, not a spark, not a single molecule of vapor. When the tanker reaches a gas station, the process reverses, but the precision stays the same. Fuel is unloaded by gravity through stainless steel delivery hoses. Each hose connects to an underground tank, and once the valve opens, thousands of gallons flow silently downward. No pumps, no pressure, just controlled gravity and careful balance. For thicker fuels or remote sites, some trucks use air assist or self-priming pumps to keep the flow steady. Each line is fitted with check valves that stop backflow the moment the hose is disconnected. While the liquid flows out, a vapor recovery hose sends displaced fumes back into the truck. It's the same closed-loop system used during loading, keeping the air clean and the crew safe. From start to finish, every drop is guided, measured, and contained. It's a quiet exchange, fuel in, vapor out, all under perfect control. Every part of a fuel tanker is built around one rule: containment. The shell may look thin, but it's a multi-layered aluminum alloy engineered to flex under impact without tearing. On top, rollover protection rails shield the manholes if the truck flips. Underneath, shear sections are designed to break cleanly in a crash, sealing the valves automatically so nothing leaks out. Every compartment has spring-loaded vents that open only when pressure rises above safe limits. If heat builds up from sunlight or a nearby fire, thermal relief valves release vapor before it becomes dangerous. Static is another silent threat. That's why bonding cables connect the entire chassis, keeping every surface at the same electrical potential. One unseen spark could ignite vapor. These cables make sure it never happens. Around it all, reflective striping, emergency shutoff levers, and rear impact guards give one last layer of protection. Together, they turn what looks like a simple trailer into a rolling fortress of physics and fire safety. Once the truck hits the highway, everything inside starts to move, but not freely. Thousands of gallons of liquid fuel shift with every brake, turn, and bump. That's where the engineering earns its name. Inside, baffles and bulkheads absorb the surge, breaking the liquid waves into smaller, harmless motions. Pressure sensors track internal loads, while G-force monitors record shocks and tilt angles in real time. When the driver brakes hard, check valves seal the lines to prevent reverse flow. If the truck climbs a hill, pressure relief vents adjust automatically to keep the tank stable. Even the temperature is constantly monitored. Aluminum expands under heat, and the system compensates for it down to fractions of a psi. From the outside, it looks effortless. But inside that tank, physics, data, and design are working together every single second, keeping chaos perfectly under control. When the delivery is done, the work doesn't stop. Every oil tanker goes through a detailed inspection routine before it's ready for the next run. Each valve, vent, and coupling is checked for residue or leaks. Pressure systems are tested, ensuring the tank can still hold up to 4 psi without losing integrity. Even small defects, a loose seal, a worn gasket, can take the truck out of service until repaired. Inside the compartments, any leftover fuel is drained or flushed to prevent cross-contamination between different grades of fuel. Foam rinses and vapor purges keep the interior clean and oxygen balanced. Technicians inspect emergency shutoffs, bonding lines, and pressure relief valves, marking every step in a digital logbook. And once a year, each tanker must pass a DOT pressure test and visual inspection, a legal requirement for every carrier on U.S. roads. It's a quiet, methodical process that happens behind the scenes, but it's what ensures that when the next load leaves the terminal, the system inside that shining silver shell is perfect, airtight, grounded, and ready to roll. So that's what really happens inside an oil tanker truck. It's not just a shiny metal tube. It's a rolling pressure system, a moving refinery, and a safety network on wheels. Next time you see one passing by, remember, inside that tank, engineering and chemistry are constantly in motion. If you enjoyed this deep dive, hit that like button, subscribe, and tell us what topic you'd like to explore next.